Then we move to the second one. And we do the same thing, we find the x and y intercept. And whatever the outcome is, we can plug it in the coordinate grid. When you graphing, the graph, if there's a solution, the graph will find it for you. Don't try anything else. Do everything how you should be doing it. If everything is correctly, you graph it correctly, if there's the solution, the graph will find it for you. That's the thing with graphing. But if you are doing elimination or substitution, you will find the solution directly without seeing the graph. So here, we're going to solve for y. I have 3x plus 4y is equal to 24. I'm solving for y. I want y to be by itself. What will you do if you are solving for y? We're not replacing anything by 0. We just move on the other side and solve y.
Subtract it.
You subtract
3x.
3x. We're not replacing anything. Solve. We're solving for y. You will have 4y equal negative 3x plus what? 24. Now, how will you get y by itself? You divide by 4. Then you will have y equal negative 3/4 x plus what? 6. This is the y-intercept form. From there, you should be able to find one of the points which is called your y-intercept. What is the y-intercept? 6. How will you write it as an order pair?
0.
When x is 0, y is 6. What is my slope of the equation? Negative 3/4. Now, the only thing I need to do is to find the x-intercept, right? If I'm finding the x-intercept, I can go back here, right? Just solve for x. Same thing again, right? If I'm solving for x, what I should do? What should I do?
Subtract 4y.
Subtract 4y from each side. Then I will have 3x equal negative 4y plus what? Plus 24. Can I get y by itself? What I need to do? Divide by 3. That's all you're doing. And in this case, x is equal to what? Negative 4 third y plus what? Plus 8. This is my x-intercept. I write that as an order pair. 8, 0. Exactly. I'm done with this problem, guys. Those are the things that I'm looking for. Then I can go and put this on the graph, right? How will I graph that? 8, 0, where will that be located? I go to the y8 unit. 1, 2, 3, 4, 5, 6, 7, 8. Then that will be 8, 0. The other one is what? 0, 6. Where is that located? Go up 6 units. 1, 2, 3, 4, 5, 6. That's 0, 6. Now the only thing I need to do is to get the ruler and put them on the line, right? On those points, you said? More or less. When I solve for y, I got 0, 6. See? More or less, then I just connect them. You may go. And I'm done with that one. Then let's go what happened with the other line. Right? Come back here. This is my the other equation. So far so good? I'm solving for y. What should I do?
Subtract.
I'm going to subtract 6x from each side. Then I will end up with 8y equal negative 6x plus what? 24. How do I get y by itself? I will divide by 8. and I will have y equal negative 3/4 x plus what? 3. What is my y-intercept? 0, 3. What is my slope? Negative 3/4. Now again, I'm going back and solve for what? Solve for x. If I'm solving for x, what I need to do? I'm going to subtract 8. This is my equation here. 6x plus 8y is equal to 24. Right? I'm going to subtract what? 8y on this side. And I will end up with 6x equal negative 8y plus 24. So this is what I end up with. 6x minus 8y plus 24. And how do I find x? To divide by 6. And x is negative 4/3 y plus what? Plus 4. And what is my x-intercept? 4, 0. Now before we even graph it, let's compare the slope. This is the slope for those two lines. What do you say about those two slopes?
Yes.
They are the same. What can you assume? They are parallel. Meaning that when you graph it, the other one, they are not going to be what? Touch. So let's graph 4, 0. Where will you find 4, 0? To the right. Count what? Different color. Go 4 units to the right. 1, 2, 3, and 4. That will be 4, 0. What is the other one? 0, 6.
0,
0, 3.
Yeah, 0.
And I write 0, 6. That was 0, 3. Right? Thank you. That would be a big mess. 0, 3. Count 1, 2, 3. Now the only thing you need to do, come with this and connect those 2 points, and you go. As you can see that they are parallel, they do not touch. Then that will be no solution to this problem. All right?